rational exponents. These are exponents that are fractions using integers. So there's one really important property, and it's probably, I guess, the only one that we're going to discuss, and that is the square root, the nth root of x to the mth power, which is equivalent to saying the nth root of x to the mth. The difference between these two, this first one here is saying take x to the m first, then when you're finished, nth root it. The one on the right is saying take the nth root of x, then when you're finished, raise it to the mth power. So the order of operations is different. You get the same answer every time. Both of those things mean the base of x raised to the fraction m divided by n. M was the exponent and n was the root. That is a property that is going to be used frequently. An example, square root of x. If there's no exponent, it's implied it's a 1. If there's nothing inside the little radical symbol, it's implied that it's a 2. So that's x to the 1/2. If you had something like the cubed root of x and you wanted to write it using rational exponents, it's going to be x to the 1/3. 1 is implied as the exponent. Also, another thing that's important, it's not really a property, but it's a fact. If you multiply a radical times itself, a square root radical that is, that's always just going to be the number. And that's because square root of x times the square root of x, when you multiply two things that are the same square root in this case, you put them inside the same radical. X times x is x squared. What is the square root of x squared? What number times itself gives you x squared? Well, it's obviously, it's going to be x. So here's a rule that you want to know. If you multiply a radical, a square root by itself, you always get whatever number is on the inside. Okay, example 1. What's the square root of 2 times the square root of 2? It's 2, for the reason that I just gave up above. Another reason that you could look at it as, you can write this as the square root of 2 times 2, which is the square root of 4. What number times itself is 4? That's the number 2. Number 2, what's the square root of 125? 125 does not have a perfect root. It's not an integer. So if we break 125 into prime numbers, think about quarters. $1.25, that's 5 quarters. And then 25 breaks down to 5 and 5. Got a pair of 5s, put 1 5 on the outside. Anything uncircled stays on the inside, so it's 5 square roots of 5. Once again, if that's too much for you, just put it into your calculator. Square root of 125 in your calculator, hit enter, write down the decimal, and then check each of these answers to see which one of those gives you the same decimal. You'll find that C does. Number 3, when you're square rooting a fraction, you square root the top and you square root the bottom. Square root of 4 is 2. Square root of 9 is 3. So the answer is 2 turds. I didn't misspeak. I said turds. You heard me. Number 4, we are multiplying 2 square roots. We know it's squared because there's no number inside the little radical symbol. You can multiply the numbers together and the letters together. So that's square root of 16 times m squared times n to the 4th. Well, the square root of 16 is 4. Square root of m squared. What letter times itself gives you m squared? It's m. The square root of n to the 4th. What letter times itself gives you n to the fourth? Well, that's n squared. So we got 4mn squared, which is answer B. We are cooking now. And you know what? I think I skipped lots of things I probably should have done. Over here, where we have these properties of rational exponents, no, that's not true. Properties, I did skip some things here. Let's squeeze this in above scientific notation. This is properties of radicals. One is if you are multiplying same square root times itself, it's just going to be whatever's inside of it. 2, if you're taking the square root of a fraction, you can just square root the top and square root the bottom. 3, which we've already discussed, if you have the mth root of x to the n, that is equivalent to x to the n over m.